When we're dealing quantitatively with Newton's laws, we're primarily looking at the second law, F equals ma. Remember, it's the net force, the sum of the forces is equal to mass times acceleration. And both this force and this acceleration are vectors. Okay. In fact, this is about the only, well, there may be one or two others, but this is one of very few equations that we'll be using throughout when we're talking about force and Newton's laws. So let's take an example. Let's say that we've got two people and they're pushing on opposite sides of a box. They're arguing about where the box should go. And person A pushes with a force of 22 newtons. Person B pushes with a force of 35 newtons, and since person B is pushing to the left, I'm going to call this negative 35 newtons. And let's say this box has a mass of 28 kilograms. And let's assume for the moment that no other forces are acting, and I want to know what is the acceleration of the box. Well, this is just applying Newton's second law. Sum of the forces, well, we've got 22 newtons going to the right, 35 newtons going to the left, so that's the sum of the forces. And the mass is 28 kilos times acceleration. So we just go 22 minus 35 divided by 28. And the acceleration then is minus 464, whatever, meters per second squared. And then, since I said what is the acceleration, I guess you should say 0.464, etc., meters per second squared to the left. If I just said magnitude of the acceleration, then you could just give the 0.464. Okay, so that's pretty simple. But we can make this a lot more complicated. Let's imagine a similar scenario. Here's our box, but this is a top view now, and we have people pushing. I can't draw people from the top. I can't draw top views of people. Just pretend these are people pushing. Whatever. On the box from multiple different angles. That does not look at all like a top view of a person. Pretend it does. Whatever. This is person A, B, C. Okay. Let's say person A pushes, and we'll say this is the same box, it's 28 kilograms, pushes with a force of 35 newtons at east by 27 degrees south. We'll say that person B pushes with a force of 28 newtons at west by 49 degrees south, and person C pushes with a force of 31 newtons due north. And I want to know the magnitude and direction of the acceleration of the box. Well, in this case, we need to do vector addition of all of these forces to find the net force. So person A pushes at 35 newtons at east by 27 degrees south. Well, that's 35 cosine 27 minus, because since it's south, it's down, that's negative, minus 35 sine 27. Person B pushes west, that's negative 28 cosine 49, and south it was also negative 28 sine 49. Then person C pushes at 31 newtons due north, straight north. You can do trig, but that's a waste of time. Since it's due north, we know that the east-west component is 0 and the north component is 31. So the net force is the sum of all of these. So we can go 35 cosine 27 minus 28 cosine 49. So our x component is 12.8, etc. And I will store that as x. And then our y component is minus 35 sine 27 minus 28 sine 49 plus 31, which is minus 6.02 and so forth, and I will store that as y. So then my net force is square root of x squared plus y squared, which is 14.1597 newtons. I will store that as F. And then at an angle of, that's arctan of y over x. Arctan of y over x, the calculator spits out 25.166. And since the x component's positive, the y component's negative, that means we are east by south, and that was 25.16. I'll just round it to the thousandths, 167 degrees. So that's the force, but remember, the question is about the acceleration. So we can just plug this in. F equals ma. Our net force is the 14.159. That's equal to mass, which is 28 kilograms, times acceleration. So we can just take that force and divide by 28. So we get an acceleration 0.5057 meters per second squared, and that is at a direction of east by, we'll call it 25.2 degrees south. Okay. So once you find the net force, you can then turn that back into magnitude and direction and find the net acceleration of the object. Okay. Now let's take an example that will apply both Newton's second and third law. Let's say we've got two boxes, box 1, box 2. They're attached to each other, or blocks. Maybe blocks on the table would be a better way of thinking about this. And let's say block 1 has a mass of, 12 kilograms. Block 2 has a mass of 15 kilograms. And these are being pushed with a force of 28 newtons. Okay. And I want to know a few things. I want to know the acceleration of the blocks. And then I also want to know the force on block 2 from block 1. Okay. So to find the acceleration of the blocks, call that A and B. For part A, well, both the blocks are being pushed by this force of 28 newtons, and if you're pushing on one, they're going to stick together and move. So we just have a net force of 28 newtons. We have a total mass of 12 plus 15, and then we want to know what our acceleration is. So our acceleration is just 28 over 27, which is whatever it is, 1.037. Call that 1.04 meters per second squared to the right. Now, if we just consider block 2 alone, this force isn't being directly applied to block 2, it's being applied to block 1, and then block 1 is exerting a force on block 2. Force on 2 from 1. So if we consider block 2 alone, it's accelerating at 1 point, so the net force on block 2 is equal to the mass of block 2, which is 15 kilograms, times the acceleration of block 2, which is 1.037, and the 037 is repeating. And so the net force on block 2 is 15.5 repeating. Call that 15.56 newtons is the net force on block 2. And this is being applied by block 1. So the force applied on block 2 because of block 1 is 15.56, which means that the force applied on block 1 because of block 2 is equal to minus 15.56 newtons. Block 2 is actually pushing block 1 to the left based on Newton's third law. Okay? Which means that even though there's a pushing force here of 28 newtons, if I consider block 1 now individually, there's that pushing force, and then there's the force on 1 because of 2. The net force on block 1 is going to be that pushing force, which is 28, minus 15.56, which is 12.4 repeating. So you can split it up either way. You can consider, and this will be useful for a lot of different problems, you can consider the blocks as a whole, or you can consider block 2 alone, or you can consider block 1 alone. And there will be many different problems we do where it's useful to break up the system in multiple different ways.